So it's a user notebook that has been developed for the data extraction for one pixel or a polygon to really show a time series, and that you can really follow how the PPI, NDVI, the seasonal trajectories, and also the start of season date, end of season date evaluate over years. So as I said, the purpose of the notebook is to have a really easy extraction of pixel and polygon data for the HR-VPP products. And it can work directly on the WKO Jupyter Notebook environment. So it's quite easy to start up and just start extracting data and using it for everything you want. And the time series can also be saved as a PNG, so you can later on reuse it or put it somewhere where you can put them together. So first is like the link that we have been showing a lot. So it's to get the notebook and scripts from our Git repository. So here is also the link. And here I have grouped the data that's inside in a bit of logical order. So I have put in an example polygon. There is one output file that is the PNG, and then we also have the Sentinel-2 reference data that is used to find out, okay, which Sentinel tile we're looking at and what's the metadata about this tile. And then we have the notebooks and the supporting functions that are necessary to run the notebook. So now we can go to the notebook itself. So the notebook is built up the same way as the other one. So first we need to install and import some, restart it. To install and import some packages. So also the Terra catalog client and some basic packages, so like the Telescope client. In the next step, we need to put in our credentials. So in this case, it's just our password for our environment. And these are then put together in a credentials format, so it can be used later on. In the next step, we have actually 3 ways in defining the pixel or polygon we want to extract. So the first one is actually in this map. So
Hello, Bert. Oh, I think we lost Bert for a minute. Okay, then I think he will come back soon. That's probably a technical, although he's still there. But okay, sorry for that. Yeah. Okay, let's come back with Bert. Oh, okay, Bert is still. Okay, there we are, Bert. Okay,
I'm back.
Yeah, you're back. Okay. Apparently you were cut out, disconnected.
Yeah.
Okay.
Yeah, because the notebook also hanged, so probably that. So here's the interactive map with all the S2 tiles.
You need to share again, I think, Bert.
Okay. Yeah. Probably.
Yeah, it's coming. Wait a minute. Yeah, okay, we see it.
Okay. So you have here the S2 map, so you can really click on one point that you want to extract, for example, and then it's saved if you know a specific point. You can also, in a later step here, define really the pixel lot long if you know it, if you really want to manually set it, or you can define a shapefile where it's here the fields shapefile, which is inside is a polygon you can use to extract data of that polygon. So in the first step, we need to select, okay, are we going to use a shapefile or just a pixel? In this case, we can just use, we'll use the shapefile to extract the data. So we can do that. And then in this box, also the outline or the environment of the shapefile is plotted with the centroid of the shapefile in the middle. So you can have really a nice overview of what is going on around your shapefile. And if you would have picked a pixel, it would be also plotting a parameter around that, that pixel. So you can play a bit around with the extent. So now it's a 100 by 100 pixel box, but you can make it larger, make it smaller. You can also use different parameters. So in this case, it was the peak of season value that has been used to display in the year 2020. Now we can go to the extraction of the data itself. So in this case, because it can take some while for the raw basic PPI series or NDVI series, I will put it to false. And you can also define which years you want to extract or you want to plot in your time series. So in this case, I put 2017 to 2020, but you can also, if you say I'm only interested in less years, you put less years, or yeah, you can play around with it. And then in the next step, you can start, you can start downloading the data that you want. So in this case, if you selected a pixel, you will only extract the pixel value. If you put in a shapefile, you will only extract the data from the shapefile, that from the raster data that is in the shapefile. So you will not download the complete tiles, only the data that is necessary to that's in your shapefile or in your polygon. So the extraction is now finished. So we can start converting the data we have received into a data frame, which then can be in the next step easily plotted and printed. So in here you can see actually all the start of seasons, end of seasons, and when the peak of the season was for every year. So you can really here see it very nicely when it was, and you can some insights on it. And here also a plot is made of the seasonal trajectories that are there. And on top of these seasonal trajectories, also the start of season in green is visible, the max of the season is visible, and the end of season is also visible for as well season 1 as season 2. But for clarity, season 2 is just grouped together in one color, because else it would be quite difficult to follow. But you can see here for the many different years that are many possible different seasons detected over all the years between 2017 and the 1st of 2021. And on the left side, you have the axis for the PPI value or the ST value. And then this is then also generated into a PNG, which you can then download to your local computer or use for other things. Also, the data behind it, you can easily extract via your class that have been created. So that's how you can easily extract the data and plot them into a nice time series and have a look at them and work with them. So that's about it.
Okay, thanks, Bert. So yeah, as you can see, at least another notebook at least there you can start from. So the first part is more or less similar to the one that we had before, because we need to access the data. But here you have a part, and especially a number of supporting functions, at least to make sure at least that this data extraction is done on a pixel, on a box level or a field level, and doing the necessary at least combinations and plotting at least of reformatting, I should say, and then plotting of the data in a more convenient way. And I think to respond on the previous question, so this 19273, you would see here then in this one a nice timestamp which you can immediately understand.
Yep.
Okay, thanks, Bert. So again, I think put in the chat also the link to the notebook already. I mean, then participants can look at that. And then I suggest let's move to the next one, Zamzang, to show the GIS integration. So, and to all the participants, if you have questions, put them in the Q&A. Then we will come back to that after this presentation. Okay, Zamzang, go ahead.
Okay, thank you, Bruno. Can you see my slides? here?
Yeah, we can see them.
Okay, great. So I will briefly explain how the HR-VPP products can be integrated with geographical information systems. So the scope of GIS is wide and includes different data types and methods of data analysis. So due to the time limits, in this presentation, I will focus on how to display and analyze HR-VPP products using existing GIS software. So I will not go through any programming code, and will only focus on the raster data type. So there are quite many GIS software available, but here we will mainly use QGIS to show the examples. And I will show how to use QGIS to display vegetation indices and seasonal trajectory, vegetation, phenology, and productivity parameters. This will be followed by an introduction of how to analyze HR-VPP data, especially VPP parameters for example, to extract the main seasons and detecting the abnormal years. So these techniques are applicable to the regional and the local tasks. So it is for the viewing VI products. So it's very straightforward to display the vegetation indices in the GIS software. So we can simply import the TIFF file into the software. And as the TIFF file of the HR-VPP products include the headers for node data and also the scaling factors. So the sum of the QGIS software can automatically do the scaling transfer. For example, here it shows the NDVI. So it's automatically transferred the digital number to the physical value. So NDVI from 0 to 1 here. And we can also use the color map to change the legend colors there. So for the seasonal trajectory, we have a PPI cloud-free 10-day images, and it have the same principle to showing the to import the image to the QGIS. And so here we can see the PPI map of May 21st in 2019. And so you can see the PPI value is from 0 to 3 there, which is also the result of a scaling factor conversion. So besides to showing the image, we can also use some plugin tools here to show the seasonal trajectories. So here, what we install here is the temporal profile tools from DHI Grass, and then we download all the image in 2019, and then put all the image to a single virtual image. So each PPI image has a one band in this image. Then we can show the temporal profile there. So VPP products are displayed in QGIS is in a similar way to the previous as well. So, but it's quite important to know that the color map about the dates. So you need to determine which year of VPP products you are using. For example, if you would like to show the start or end of season dates for 2019, then you probably need to use the color bar of the 2019 there. So here it shows the T-plot, which means the total productivity, so sum of PPI in the growing season of 2019 here. And you will get data in a digital value if you are not using GDAL to import some HR-VPP products. So previous examples are shown in QGIS, which is already used GDAL to import the. They have GDAL integrates to read the TIFF file. So for example, if you use MATLAB or other software directly read the TIFF file, then you will get the digital number there. So then the information of products specification information is quite important. So they provide many useful informations, especially the raster coding. So shows the what's the valid range for physical value, what's the range for digital number, and what's the null value there. And also the other one is quite important as well, is the scaling factor. So to convert between digital number and the physical values. So previously, there's a question asking about what's the difference between season 1 and season 2. So the seasons are assigned to the year based on the peak of the season, the timing of the peak of season, and the season are assigned in the temporal order to the first and the second season. So, so the first season will cite as say season 1, and the second season will cite as a season 2. So that will create so we'll let a problem that the main season probably occur in the second season. So we can see the second season is a little bit larger than the first season. So probably this is the main season. So what we can do is there's also questions. So which season should we use? Then my advice is to probably consider both season and then extract the main season for analyzing. So so this can be used for quite many tasks. So here is logic to how to extract the main seasons. You can so firstly we need to define a criterion for which VPP parameters can do this determination. So so here we use T-prod, total productivity. So it shows the PPI sum up during the growing season. So we create 3 simple logic line here. So if T-prod season 1 is larger than T-prod season 2, then we think, okay, season 1 is the main season. And in contrast, so the T-prod season 1 is smaller than T-prod season 2, then we think, okay, season 2 is the main season. Then we can create this main season mask. Then we apply this mask to all the phenology and productivity parameters. Then we can get the main season VPP there. So here is compare the season 1 and the main season. Actually, season 1 usually it captures most important seasons there, but we still can see some this continuity in the spatial showing there. So after selecting the main season, we can see the second season sometimes will replace the first season. For example, this field. So it's totally replaced by this season 2, and also this field as well. So Europe experienced a severe drought in 2018. So this extreme climate event severely affects the growing season of southern Sweden. So here now I will show how to observe the 2018 droughts within the HR-VPP products. So here we can see the T-plots of a main season in 2018 and 19. So we can see a big difference here. So we can see the big difference here. So we can see here is the urban area, and here are the grassland and the forest. So we can see the grassland have a much lower T-plot here, and the forest land have actually doesn't change that much. So sorry. So we can use so QGIS to actually analyze this one. So I mentioned the temporal profile plugin here. So we use before, then we use this tool to see what's the trend from 2017 to 2021 here. So for example, for the grass, okay, now I'm not showing any image from HR-VPP products. So this is the background image from Sentinel-2 data. So we can see here is a grassland here. So we can see, okay, T-prod actually decreased quite a lot in 2018 and actually have a recovery for the coming years. And here's some gardens in the house. So we can see quite similar patterns there. So in 2018, we have a very significant decrease there. And how about forest here? Then actually we can see the big drop in 2019 there. So this is probably come up with a different reaction between forest and grassland to the droughts. So probably the grassland is more sensitive to droughts in the drought year, but the forest is more sensitive to the next coming year because of they have some groundwater to survive during the drought year. But after the drought year, is lack of groundwater, so they decrease their total productivity there. So here is some comparison between these two different vegetation type there. Yep, so that's everything I would like to show. Thank you.
Okay, thanks, Zhang. So I think this shows a nice overview, at least, how easy it is if you just download on a small scale, let's say a tile, at least the VPP data for the several years, which you can use the notebooks before to download the data, at least to your local computer, and then you can do this kind of analysis. And it also shows a nice example where you can see that the grass is immediately affected by drought, while with the forest there is a kind of a delayed response on drought. So okay, that brings us to the end of the second part in the demo, so an analysis of the data. So let's again take a couple of questions. If you have some questions, put them in the Q&A.